All right, hello. This is 9-7, Factoring Special Products, and it is not a mistake that I have gone from 9-5 to 9-7 in your steps. 9-6 is kind of difficult, and so what we found out is actually if we put it at the end of this chapter after 9.8, it's much easier for you to do because you have lots of other experiences leading into 9-6. So we are skipping it for the moment, and we're going to talk about 9-7, which is factoring special products. So a perfect square trinomial is a trinomial of the form a squared plus 2ab plus b squared, or it could have a minus sign in front of the 2ab, so a squared minus 2ab plus b squared. If this looks kind of familiar, it should, because this is the section I've been talking about that matches up with 9-3. So these were your 9-3 notes. And right here in your notes are those two trinomials that we had been talking about. And we were squaring a binomial pattern to get those two trinomials. So now we have the trinomials, and we're going to go back to the binomials. Okay, so to do that, first of all, we may have a squared minus b squared. And that pattern to get that is a plus b, a minus b. So it's the two numbers with a plus sign and a minus sign. And this is called the sum and difference pattern. The sum and difference pattern. One's a sum, one's a difference. Okay? So what you would do to find the a is you would kind of like unsquare this, right? You're going to square root. What times itself is 9? 3. What times itself is x squared? X. So the a term is the 3x. The b term is what times itself is the 4. So 2 times 2. We're ignoring the minus sign right now. 2 times 2 is 4. This pattern, if I have a perfect square and a minus sign, I know I have the sum and difference pattern automatically. So here are my 2's, and then one is a positive and one is a negative, so to speak. One's plus, one's minus. Okay, so we're going to practice our sum and difference pattern. So I have z squared minus 81. Is this a perfect square? Yes. Is this a perfect square? Yes. Do I have a minus sign? Yes. Those are your 3 checks. Perfect square, minus sign. If you do, you take this shortcut. So that would be 9 squared is 81, so it's z plus 9, z minus 9. All right, next one. What times itself is 16x squared? 4x times 4x. So the square root of 16 is 4. The square root of x is x squared. So just a reminder about square roots. This is the square root. What times itself is that number? Okay, so if I said what's the square root of 25, what times itself is that number? What times itself is 9? 3. So I have 4x plus 3, 4x minus 3. And if you FOIL it out, that's what you're going to get, because those middle terms, the outer and the inners, will cancel. We would have had a positive 12x and a negative 12x. They make 0. That's why we just have the first and the last term in the FOIL pattern. All right. 5b is what multiplies together to get 25b squared. So I have a plus 5b, a minus 5b. The last one, we have it a little bit different this time. Now, it looks like it's pretty good. Here's a perfect square and here's a perfect square. But we want to put it in simplest form. And because there is a common factor between 4 and 16, we actually can factor it out first. So this one is a special problem. It has an extra step. I'm going to factor out a 4, and watch what happens when I factor out 4. 4 divided by 4 is 1. 16 divided by 4 is 4n squared. See, is this a perfect square? Mm-hmm. Is this? Mm-hmm. So the 4 actually came out first. 1 times 1 is 1. 2n times 2n is 2n squared. So this is actually a 4 on the outside, 1 plus 2n, 1 minus 2n. And you're going to have to factor them completely. That's what the directions will say. Factor completely. So if you would have gone from here and had just done 2 plus 4n 2 minus 4n, these all have a common factor in there, so you would not have factored it completely. So this is the form we'll have to take. Okay, so pause the video and do the checkpoint below and then come back and see if you got them. So number 1 is x plus 10x minus 10. 2 is 7y and 5, and you've got your sum and your difference. C minus 3d, C plus 3d, and then this one you would have said, hey, these are not perfect squares. I have a binomial. There is a minus sign in between, but they're not perfect squares. But when I looked at it closely, I said, there's a 5 that can be factored out of both of those. And after I factored out the 5, I was left with 9 and 16, which are perfect squares. So this one had one extra step in it. All right, the next page is the perfect square trinomial pattern that we were talking about at the very beginning of the notes in 9-7. So a squared plus 2ab plus b squared, that's basically taking the a and the b and multiplying by 2 to get the middle term. That is a plus b, the quantity squared. And reminder, that's a plus b times a plus b. The outer and inners are both a times b, so that's why it ends up being 2ab, because they're the same thing. This one would be a minus b. So what you need to do is you need to recognize the pattern and then take the shortcut. So I say, is this a perfect square trinomial? Is the first term a perfect square? Yes. Is the last term a perfect square? Yes. Is this term 2ab? Well, a is x, b is 4, and if I multiply that by 2, do I get the middle term? I sure do. So then I take the shortcut, which is a plus, x plus 4. Okay? So basically, if you divide that by 2, there's your 4. That's where that number 4 is coming from. This is x plus 4 times x plus 4 to get the a. Okay? So now this one has a minus sign. That's okay. Perfect square? Yes. Perfect square? Yes. X times, what's that? 3 times 2. That's 6. So there's my number that I multiplied by 2. It's the 3. So this becomes x minus 3 now, because there was a minus sign there, and it's squared. All right? So let's do it again here. Perfect square, yes. Perfect square, yes, that's 8. And then it's double the x times the 8. They just put it in a different order than I did. That is 16. There was a minus sign there, so a minus sign goes in the middle. That's this term and this term. X minus 8, the quantity squared. All right, that would be a 2y. This would be a 3. So then I do 2 times the 2y times the 3. So this is 6y times 2 is 12y. Bingo. What goes in here then? The first term, the minus sign, and the last term. Okay, the next one, that would be 3s, and this would be t. Check to see if the middle term works. 2 times 3s times t. 2 times 3s is 6s. Add a t is 6st. Yes. So it's the first term plus this time the last term, because that was a plus sign. All right, now the next one's not going to work because -3 is not a perfect square, so we need to factor it out. If I take a -3, I divide each one by -3. This is what I'm left with. Z squared, -8z, because I factored out a negative, and a positive 16. The -3 just hangs out there the whole time, and then I check this. So perfect square, 2 times 4 times z. I'm going to put parentheses around there to do the pattern we were doing before, is 8. 2 times 4 is 8 times z. Yep, it is. So the -3 stays, and then it's z minus, because there was a minus sign, 4. Okay, pause and see how you do. Okay, so the first one works. It's a perfect square trinomial, and here's how I'm checking it to make sure the middle term works. A times b times 2 is 14x, so it's x plus 7, the quantity squared. Perfect square, I double checked it. 3y times 1 times 2 was 6y. The minus sign goes in between. Okay, the next one, 4x, 5y, and I do my check here. 4x times 5y times 2. 20xy times 2 is 40xy. The minus sign goes in between. This one I can tell right away it's not going to work, but I can factor out a negative 5. When I do, all the signs become positive, and I'm left with r squared plus 4r plus 4. And then I say a times b times 2. Yes, it's 4r. The plus sign goes in between. Okay, so let's go to the next page here. So basically what we're going to do now is the same exact thing. We're going to use our shortcuts, and then what we're going to do is we're going to solve. So we're back to solving again, finding the roots, finding the solutions. So perfect square trinomials do not just have to be whole numbers. Is something times itself 1/4? Yep, sure is. What's a half times a half? 1/4. Okay, so I have a perfect square trinomial. So one way I could do this is by identifying that this right here is x plus 1/2 the quantity squared. Or if I wasn't sure, I could multiply each side by 4. So I multiply everything on this side by 4 and everything on this side by 4. So that gives me 4x squared plus 4x plus 1 equals 0, because anything times 0 is 0. And now this might be more obvious to you. Perfect square, 2x times 1 times 2 is 4x. So this is 2x plus 1, the quantity squared. So what I can do then is I use my zero product property. 2x plus 1 times 2x plus 1. There are my two things being multiplied together. Well, it's the exact same term, right? So I don't need to write them separately in an or statement like we have been doing. I'll just write the 1. And then I solve for x. So that ends up being 2x equals negative 1, divide by 2, x is a negative half. Now I would have gotten that if I had done from here, if I had done x plus 1/2 the quantity squared equals 0, I would have gotten the same thing. But I'm just letting you know that you can always take that step. Okay? So before we do that example 4, I want you to pause the video. Actually, we'll do one more together, and then you'll pause and do these two down here. Okay, so is this a perfect square trinomial? It's m times 4. They're both perfect squares times 2. That's 8m. Is that the middle term? Yep. And there's a minus sign, so I write the minus sign. The quantity squared equals 0. Don't forget that squared sign. So we can just set one of those equal to 0. Sorry about that. All right, so it's m minus 2. The quantity, m minus 2, and I don't even need parentheses anymore. I lost myself here when the phone rang. I don't need those. Add 2 to both sides. M equals 2. So there's only how many solutions to these special ones? Just one, right? Just one. All right, do 10 and 11, but pay attention to 11. It's not a perfect square trinomial. See if you can get it. Okay, did you get w equals negative 8 for 10? It worked out. It was a perfect square trinomial. You take your shortcut, w equals negative 8. Now the next guy, I gave you a heads up, that's not a perfect square trinomial. Which one is that? That's the sum and difference pattern, isn't it? So that's t plus 11, t minus 11. Perfect square, minus sign. So it's a squared, the b squared, and sum and difference. Okay, so we'll have two solutions to this guy. T plus 11 equals 0, or t minus 11 equals 0. Negative 11 and positive 11 are the two solutions. It could be one or the other, or it could be both. So we just say negative 11 and 11 are the solutions. All right, you're doing great. Let's go back to our vertical motion model problem. We're going to see this for the rest of the year, so just start to embrace it. Okay, so we have a falling object, and it says a brick falls off a building from a height of 144 feet. So that's my initial height my brain is thinking right now. Okay, initial height, 144. After how many seconds does the brick land on the ground? Ooh, I got another clue. What's the height of it if it lands on the ground? The final height is 0. That's 0 feet right there if it's on the ground. So it says use the vertical motion model. The brick fell, so its initial vertical velocity is what? Well, you may think that the clue isn't there, but initial means starting. Where is the brick falling at the very first, like before it starts? No, it's on the wall still. So its initial velocity is 0. It's sitting on the wall still. So that's going to help us out a lot. And then it says find the value of time in seconds for which the height in feet is, and we just figured that out, the final height is 0. So hopefully by now the vertical motion model is starting to stick in your brain. If not, it's time to start memorizing it. It's h equals negative 16 t squared plus vt plus s. So this has to be memorized. It's not going to be provided for you. Start getting it in your memory banks. Now, what did h stand for? It was the final height. That was 0. That's on the ground. We're looking for t, so I'm not going to worry about filling in for t right now. However, what did we say the initial vertical velocity was? That's the v, and it's 0. So what happens to that? See you later, right? So that's gone. So I'm not even going to write it. That's gone. Plus s. S was the initial height. And that's the tricky one because you think it's like seconds. No, it's initial height. And what was that? It's 144. Okay, we are really close to what? We're really close to a sum and difference pattern. Perfect square, minus sign. No, we have a perfect square. We don't have a minus sign, and we've got a negative out here preventing us from making that a perfect square. So I'm going to factor out a negative 1. When I do that, I get 16t squared minus 144. Okay, so we factored out a negative 1. It's still equal to 0 over here. So, do I have a perfect square? Yes. Perfect square? Yes. Minus sign? Yes. Here you go. 4t, 4t. 12, 12, sum and difference. That negative 1 still stays out there. Now, some of you don't like that 0's on this side, so you can always just erase that and put equals 0 over here. Now I have 3 things being multiplied to equal 0. Well, the first one would be negative 1 equaling 0. Does negative 1 equal 0? No, so you just kind of get rid of that guy. The next one is 4t plus 12 equaling 0, or 4t minus 12 equaling 0. So I'm going to do my work over here because, of course, they don't like to give me enough room. 4t plus 12 equals 0, 4t minus 12 equals 0, and then solve for t. So 4t equals negative 12, and over here 4t equals positive 12. Divide everything by 4. T equals negative 3, or t equals 3. So that's what goes over here. Now you need to think about this for a second. Time. This is seconds, right? Can I have a negative 3 seconds in a real-world problem? Absolutely not. This is not a possibility. So the brick lands on the ground 3 seconds after it falls. Only the positive answer was the right one. Okay, so over here on number 12, it says, what if, in example 4, the one we just did, suppose the brick falls from a height of 225 over 4 feet. After how many seconds does the brick land on the ground? So instead of the 144, we're going to plug that in to our model here. So 0 equals negative 16t squared plus vt, that's the initial vertical velocity is still 0, plus 225 over 4. Okay, so just because it's a fraction doesn't change anything. I'm still going to factor out this negative 1, and I'll put the 0 on the other side for those of you that liked it. I'm going to move this over a little bit. So negative 1, 16t squared minus 225 over 4 equals 0. So I'm going to say perfect square. Is this a perfect square? It is. What times itself is 225? 15. What times itself is 4? 2. So it's just 15 over 2. That's my perfect square that I'm going to get. So it's a negative 1, 4t, and 15 halves. There's my plus sign, 4t, and 15 halves, with my minus sign equals 0. Okay? If you wanted, you could have gone through and multiplied everything by 4 like they suggested, and then you would have gotten rid of the fraction. I'm just going to go with this method, but you certainly can do that. Okay, so from here, go ahead and solve and see what your final answer is. Pause the video. All right, so here's where I am. I set them all equal to 0. I subtract 15 halves and add on that side, and then I have to divide by 4. Well, dividing by 4 is the same as multiplying by what number? It's reciprocal, right? 1/4. So I end up with a negative 15/8, which we know cannot work in a real world problem. I can't have negative seconds. So time is 15/8 seconds, and you're probably not going to say that. You probably would say the brick lands on the ground. After 1.875 seconds. And you probably wouldn't say that either. You'd probably say almost 2. But if they wanted us to be specific, that's it, 1.875 seconds. All right, head on to your practice.